This is testimony of Andrew Dessler before the Committee on Energy Resources of the Texas State Legislature on March 8, 2007. I am testifying on a bill to create a task force to look into climate change and how it might affect the state of Texas.
Chair calls Andrew Dessler. Again, Texas A&M University. We're being outdone by Aggies this morning, folks.
Never outdone.
Oh.
Just a lot here. Thank you for the opportunity to address the committee about HB 722 concerning the establishment of Texas Global Warming Task Force. My name is Andy Dessler, and I'm an associate professor in the Department of Atmospheric Sciences at Texas A&M. To put this bill into context, let me first summarize what the scientific community understands about climate change. First, the climate is warming. Second, it is virtually certain that humans are contributing to this warming, and it is very likely that humans are now the dominant driver of the climate. Third, if we do nothing, the planet will likely warm by 3 to 7 degrees over the next century. Fourth, there is a serious risk of severe impacts if such warming occurs. These conclusions are based on the most recent report of the Intergovernmental Panel on Climate Change, often referred to as the IPCC. This report was written by hundreds of climate experts from 130 countries. It was it's based on the peer-reviewed scientific literature. The report has itself undergone several layers of review, including expert peer review by thousands of other climate scientists, reviews by over 100 IPCC member governments, and a public review. The IPCC's last report in 2000 was reviewed and endorsed by the National Academy of Sciences, and its conclusions were also endorsed by the American Meteorological Society, American Geophysical Union, and American Association for the Advancement of Science, and others. In the end, the
Excuse me, okay. Just a second. The clerk will show Chairman Chisholm present. Thank you.
In the end, the IPCC reports are perhaps the most thoroughly vetted scientific documents in the history of science. IPCC reports are therefore widely regarded as the most authoritative summaries of what we know about global warming and how confidently we know it. Given that the scientific community has established that human-induced global warming is occurring and the risk of severe impacts is significant, the next question is what the state of Texas should be doing about it. First, it is crucial that we put a price on emitting carbon to the atmosphere. Decades of economic research tells us that when a resource is free, people will not take action to conserve that resource. Thus, emitting carbon dioxide to the atmosphere is presently free, and little effort is made to avoid emissions. Hence, we must begin to think about ways of appropriately pricing.
Mr. Chisholm?
Is it too early to ask questions?
No.
I just got here, and I don't have long to stay, so I want to make my time as valuable as possible.
And you can ask questions anytime you want to, Mr. Chairman.
I just want to make sure your witness is okay with that, because if not, I'll just...
No, please.
Okay. I mean, I don't want you to have to lose your place.
I was called professor. I'm used to being interrupted.
You got it written out, though. Okay. Well, first of all, we talk about carbon, and do you agree with the statement that carbon is global?
Yes.
Okay. So wherever carbon gets into the atmosphere, be it Texas or California or China.
That's right.
So if you're going to price carbon, do you propose that we price it worldwide?
Absolutely. There's no way to solve the problem without eventually reaching international agreement.
Okay. So we need an international agreement that includes all countries.
That's right.
Do you know what the world inventory of carbon in the atmosphere is now?
About 700 gigatons, plus or minus a few tens of gigatons.
So we virtually have I guess the next question is you propose that we reduce that, right?
Absolutely. Well, we have to stabilize it. It can be extremely
the first thing you do is stop the input.
That's right.
Okay. All right.
Well, let me put it this way. I mean, speaking as a scientist, I'm not going to tell you what to do, but I can tell you the trade-offs. And if you want to stabilize the climate, which as a citizen I believe should be a goal, we have to reduce emissions of the entire globe by about 60 to 80% relative to today's emissions level.
Because you have natural causes.
Yeah, well, there's
produce
natural
carbon.
sinks. There's small natural sinks that take carbon dioxide out. And so we can emit about 2 gigatons a year and stabilize the amount of CO2 in the atmosphere. And that, it won't go up. Right now we're emitting about 8 gigatons.
Okay.
Hence, we must begin to think about ways to appropriately price emissions of carbon dioxide. Most discussions on this topic revolve around market-based mechanisms such as permit-based carbon trading schemes. One of the mandates of HB 722's task force is the analysis of the feasibility of such a system, which is a good first step. It is important to recognize that the point of putting a price on emissions is not to reduce emissions through energy rationing. That approach will never work. Rather, the goal of putting a price on emissions is to spur the development of new technologies. Such new technologies will produce energy with little or no emissions of greenhouse gases or allow us to perform socially beneficial activities while consuming little or no energy. Now, some of you might oppose carbon emission regulations for economic reasons. For those of you who fall into that category, let me make a different argument. Regulations on carbon emissions are a virtual certainty. It is not a question of if, but a question of when and exactly how much. Momentum is growing in the U.S. Congress and throughout the world to take action on global warming. Most serious presidential candidates of both parties support action on climate change. Here in the United States, California and several other western states have formed a regional partnership to cut greenhouse gases, while 7 northeastern states are setting up a similar arrangement. When the inevitable occurs and binding national regulations on emissions are passed, Texas companies will either be buying technology from companies in places like California or Germany, or selling technology developed here in Texas to the rest of the world. Setting a price on carbon now positions the Texas economy to take advantage of the emerging market for energy and emission-saving technology by moving first, instituting regulations now rather than waiting for national regulations. Those regulations now will spur research and development and innovation and lead to the development of new technology. When the rest of the world adopts regulations, which they will, Texas can export this technology. All right, let's turn to conservation. In the short run, the cheap...
Let me cut in again. Clerk will show Chairman Court present, please. Thank you. Go ahead.
Let's turn to conservation. In the short run, the cheapest source of new energy is to not use it. A vigorous energy conservation program will allow us to slash the growth of energy demand, reducing the need to build new power plants. To this end, the task force is mandated to explore ways to conserve energy, something on which little effort is expended today. This is a crucial aspect since it is generally agreed that energy conservation must be an integral part of any plan to address global warming. I emphasize here that the goal of conservation is not to force changes in our lifestyle. Energy analyst Amory Lovins famously said that what we want is not energy itself, but cold beer and hot showers. The goal of conservation is...
You don't propose to tax that.
No. The goal of conservation is the procurement of goods and services that we value while using less energy than we presently do. To this end, a well-designed conservation program will spur the development of new technologies that will lower the energy intensity of our lifestyles, and I add, can be exported to other states and other countries. I would also recommend one additional charge to the task force not included in the original bill. Given the lags in the climate system and the fact that it will likely take decades for the world to make the 60 to 80% reduction in greenhouse gas emissions for the required climate stabilization, even under the best scenarios, we will likely experience something like 2 degrees of warming over the next century. To the extent that we cannot avoid this warming, we need to be ready to adapt to it. Government policy can increase our citizens' adaptive capacity in several ways. Governments might undertake specific adaptation measures by spending public money to build seawalls, for example, or they might require adaptation measures by private citizens, such as changing zoning codes to restrict building in coastal areas, floodplains, or other vulnerable areas. Of particular importance is the role of information. Climate predictions, impact studies, information about potential responses, or technical assistance in promoting adaptation. Such information can help people shift from reacting to climate change as already occurred towards anticipating future changes. As Katrina showed us, adapting to anticipated changes is more effective and less costly, particularly for planning and investment decisions with time horizons of decades or longer. The Global Warming Task Force should be charged to study ways to reduce the state's vulnerability and increase its resilience to climate change. This could be connected to the task force's first charge to assess and update the 1995 report, The Impact of Global Warming on Texas. In summary, addressing the global warming problem is like piloting a supertanker. If you suspect there are rocks in the distance, you have to start turning the ship now. By the time the rocks are clearly visible, it's too late to avoid them. For climate, the warning signs are apparent. By the time we're certain about the severity of the impacts of climate change for the state, it will be too late to head them off. Thank you.
Thank you. Any questions, members? Mr. Cribb?
When did the global warming start, this trend?
Well, it depends on, okay, so global warming, as it's generally used, refers to human-influenced climate change. And the scientific community believes that we can attribute human influence to starting about 30 years ago. That's when we can start saying that warming is due to humans. It was warming early in the 20th century. We really don't know why, because we don't have good measurements of the climate system.
When did this trend start? I mean,
climate...
I'm not talking about people. When did this thing start getting warmer?
It's been warm and it's been cold in the past. The most recent warming started in about 1975. From about 40 to 75, it was basically flat, and then it started warming in the mid-70s.
No. When's the time that it warmed before that?
It warmed from about 1900 to 1910.
Why did it warm then?
Well, we don't really know. We don't have, if you look at data, since about the mid-1970s, we have excellent data on the Earth. We have satellites, we have measurement stations. If you go back 100 years ago, we don't really have measurements of all the climate forcing. It could have been the sun 100 years ago. It could have been CO2. We just don't know. But for the last 30 years, we have outstanding measurements, and we can essentially eliminate every possible cause except humans. And humans fit theoretically, and there's no competing hypothesis. So we're quite certain that for the last 30 years, humans are driving the warming. Before that, we just don't know because we don't have satellite. We didn't have satellites up 100 years ago.
So there's geological evidence that there's been warmings in the past?
That's absolutely right.
And there's been trends then it's cooled off after that?
That's right.
And what caused those? As a scientist, what can you tell me?
Right. Okay. So if you look at we can look at the historical record. We can see the temperatures going up and down, and for all of those, we can identify a reason. So things like changes in the Earth's orbit. The famous ice ages are driven by changes in the Earth's orbit. If you look at, there was a long cooling from about 50 million years ago to about 10 million years ago, and that was caused by a change.
Wait a minute, Earth's orbit?
That's right.
Caused it? Are you saying that the orbit, that we're set at a certain place away from the sun, and that it's mathematically you can show if you move the Earth that there will be warming or cooling?
That's right. The Earth's orbit is not a perfect unchanging circle. It's actually an ellipse. And the Earth's orbit changes in 3 different ways.
And who was it that told us it's an ellipse?
Newton or Kepler, one of those guys.
It's been a few years we've known that, right?
That's right. So the Earth's orbit changes in 3 different ways. The eccentricity of the orbit changes, how elliptical it is changes. In addition, the tilt of the planet changes. And in addition, what we call precession of the equinox, which is the time of year when the Earth is closest to the sun. Now, those change on time scales of 100,000, 40,000, and 20,000 years, respectively. And if you look at the ice ages, we get an ice age about every 100,000 years, and that's driven by changes, we think, in eccentricity of the orbit.
So we actually, for the Earth to maintain human life, it has to be at a particular place in the solar system with its orbit from the distance from the sun?
Well, I don't know if it's need to maintain human life. I'll say that
all of the planets, whether they are, you have to be able to maintain their mathematically you can show, as I've been told at least, that it's through math you can show exactly where we need to be to cause all this. Is that not correct?
Yeah, I mean, people that sort of study evolution of life talk about a life zone. And that because the planet has to be warm enough to support liquid water, but not be too hot. And so there is a range of orbits. But the Earth doesn't vary close to that much. The variations I'm talking about are very small compared to sort of the width of what they call the life range, where you have liquid water, but the water doesn't boil. I mean,
So now, when have we seen a change like we've seen in these last few years? When is the last time we saw a change like this?
Well, as far as we know, never.
I'm just talking about the temperature change. I'm not talking about who caused it or what caused it or what speculation is that caused it.
Okay, well, if you include rate of change as well as magnitude of change, it's possible the changes we're seeing now are unprecedented in the history of the planet. Changes at the end of an ice age, for example, that are actually quite large, take place over 10,000 years. It took us 10,000 years to get out of the last ice age. So you say, okay, well, it's 8 degrees about since the last ice age. Take you 10,000 years to do that. That's a pretty slow rate compared to a few degrees per century, which is what we're facing now. So this is potentially unprecedented. Now, the caveat is, as I said before, we only really have good data for the last 30 years. So there's uncertainty. As a scientist, I have to tell you there is uncertainty in that statement, but we really don't know of any changes in the planet that are as fast as the changes we're now experiencing.
But that's just based upon our knowledge. Not we don't know whether it's happened this way before or not, or what's caused it before.
But we don't think there's really no reason to think it has happened. I mean, again, we understand.
We don't know. That means it didn't happen.
No, I'm saying is we understand the things that can change the climate. And there's really no reason to think that the climate can really vary. I mean, the orbit changes very slowly. And so that's why you get these ice ages every 100,000 years, say. All the other things you can think of tend to be pretty slow. Change in the arrangements of the continents, for example. The sun doesn't change its brightness that quickly. At least we don't have any evidence that it does. There's really it's an open issue. There's no reason to think that changes like we're experiencing now have ever happened in the past or are common.
Bob, I think it was Newton, by the way, that showed that mathematically
you may be right.
We can show that. I'm fairly certain I am.
Oh. I'll defer to you.
I'm not a scientist and I don't teach this stuff, but I just so we think it's happened before, and at this time it started about 30 to 40 years ago.
I'm saying we don't think it's happened before. It's an open issue.
You think it's been warm before, don't you?
But the rate of change that we're experiencing.
I'm not talking about rate of change.
Okay.
I'm talking about
if you're talking about absolute temperature.
I'm talking about global warming. That's
right.
what I keep hearing about, global warming. Okay. Has it happened before or not? Yes or no? No. Yes or no? Has it happened before?
I cannot answer that question as phrased like that. Let me answer it this way. The average global temperature has been warmer than it is today.
How many times do you know that it's happened before?
I would say several.
And how much warmer in those times did it get than it is today?
Significantly warmer. If you go back 50 million years ago, there was, fern trees at the poles and crocodiles in Canada. So there was of course, sea level was 100 feet higher then, but, it was warmer.
You said something about Katrina. What's Katrina got to do with this?
What did I say?
Didn't you say something about Katrina in this, about preparation, or we learned something about Katrina? I thought I heard Katrina. Did you say something about Katrina? Yeah, you said something about Katrina.
I have to be honest.
You're not saying that the hurricanes are caused by global warming.
No, I certainly didn't say that.
Yeah, you said Katrina. Everybody up here heard it.
But he didn't say that it was caused.
I think he was talking about his ex-girlfriend.
I don't know. Maybe it was.
I don't think I did. If I did,
well, you did say something about Katrina. Yeah, we all heard you say something about Katrina. Well, that's all right. I just was.
Mr. Tanchu, you had a question?
Yeah, you just said that the Earth is 50 million years old. Isn't it really 6,000 years old?
Wait. So I said the Earth was 50 million?
I don't know.
Mr. Chisholm was gone.
Oh, okay. I'm sorry. I thought we were. When you said that the Earth is a million years old, I was a little bit confused. We had some literature passed around earlier that in this session that said that the Earth might be a lot less, and I was wondering when you were going to talk about the time that man and the dinosaurs walked the Earth together.
Not in 5 minutes. I couldn't get to that.
And Mr. Anchia, Mr. Chisholm has not listened to people. Well, never mind.
But let me say one thing. I sort of understand the line of questioning. Let me assure you that we're quite certain, the scientific community is quite certain that humans are causing this warming. And you can say, well, in the past, it's been as warm as it has been now, but we understand why those variations occur. If you go back 400,000 years, the last time we think the Earth was much warmer than it is now, we know that based on the orbit of the Earth, the orbit was different than it is now, and that's really what explains what we call marine stage 11. There's really no explanation for the present increase in temperature other than humans.
My son-in-law is an engineer, the reason I was asking it. We talk about this a lot, and he is quite interested in the issue, and he's trying to make me interested in the issue. And I think what you're saying is that if we can have some impact by having some policies that are not too onerous of policies, to keep the same quality of life that we know now, by making some changes to maintain this, because this is a certainty. If we can, we don't know what it would be like if we raise the temperature 7 degrees, but what we do know what we have now, and to maintain what we have now by making some changes that are not too onerous, but to still in the trade-off to keep the quality of life that we have, then we ought to be looking at those.
That's right. That's right. And I think that if you have a policy which is too onerous, it won't have any kind of support. And so you almost have to design policies that allow people to sort of maintain their standard of living. I mean, if you don't,
and we're talking about maintaining a standard of living, if we can get, and we hope to see it global, not only here, but global, the standard of living that we have.
That's right. Exactly right.
But seeking to maintain it for everybody.
That's right. I mean, I think it's not ethical for us to tell developing countries you can't develop. And so I think most people, and they'll never agree to that. So that's dead in the water. So you have to allow everyone to develop. You have to allow people to live at the standard of living we've become accustomed to, but do so in a way that is that's more energy efficient and environmentally conscious, and that requires new technologies. The question is, how do you develop new technology? And the way you do it is with market-based and price incentives. You put a price on doing the thing that you don't want people to do, and people will develop ways to not do that. I mean, that's, it's economics.
Necessity is the mother of invention.
Exactly. And so, we have a lot of evidence from previous environmental issues that when you put a price on some bad action, like emitting NOx and sulfur from power plants, it turns out it's really cheap to fix those. And I'm not saying climate change will be cheap or easy, but we have to try.
It's like taking the lead out of gasoline and telling you got to come up with something else, and they came up with something else.
Exactly. Is that right? I mean, people solve these problems. It's like fluorocarbons. Before the we banned fluorocarbons for the ozone hole, people said you could read all sorts of apocalyptic predictions about millions of deaths, banning air conditioning. You have to give up your air conditioning, you have to give up your refrigerator. And all of this turned out to be false because the smart guys at DuPont figured out a way around it. And again, climate change is a harder problem, but the way to address it is to give people incentive to develop new technology. And I see this bill as being a good first step for that.
Well, I never thought that the whole time I'd be here that I'd ever agree with the author of this bill on anything.
Any other questions, members? Mr. Kirby?
Andy, I just wanted to compliment you on your testimony. I think you were reasoned. You were thorough. I appreciate your testimony.
Oh, well, thank you very much.
Thank you for coming this morning, and I'm sure you'll be back in front of this committee because we're going to continue to talk about energy and the new and ever-present things that we have available.
Good.
Thank you.